Okay, so we have something in organic chemistry in terms of choosing solvents that's called leveling effects. And we are going to probably memorize most of the solvents that we use, so it's not a really big deal. But since we have an easy tool available to us, and that is our understanding of acidity, since we have this easy tool available to us, we want to talk about why we choose the solvents that we use. And it certainly is possible that a question will come up in a quiz or exam that asks specifically about leveling effects. So let's talk about it. An important skill is to be able to choose an appropriate solvent for an acid-base reaction. Okay, so the solvent, of course, if you're choosing something that's just supposed to be there to carry the two molecules together, the solvent should just be able to surround the reactants and facilitate their collisions without itself reacting. So you don't want a solvent that's reactive, of course. Now, water is a fantastic solvent and we'll use it a lot. But since it can act as an acid or a base, it has what we call a leveling effect on strong acids and strong bases. In other words, acids that are stronger than H3O plus cannot be used in water. Bases that are stronger than OH minus cannot be used in water. And why is that? Let's talk about it now. So suppose that you're using water as a solvent for a reaction like this. Do you see acetate here? Let me get my marker out. Here's my marker. We'll use orange. Okay, so if we've got water here, well, it turns out that what we're going to have, if this were the solvent, we would have acetate, which would come over and take these are offset. Sorry, folks, these are offset. This pKa is supposed to be here, and this pKa of water is supposed to be here. Okay, so we've got acetate, which is going to abstract a proton from water, and it's going to make acetic acid and give hydroxide in its place. Okay. Well, now since this is the lower pKa, it's the stronger acid. It's going to go in this direction, right? Because the stronger acid gets to act like an acid, it's going to go in that direction. So in this case, it's okay to use water as a solvent if you are using acetate in some reaction, right? Because it's not going to, this is going to not happen very appreciably. If this is about 5 and this is about 16, then this is over 10, 11 billion times weaker of an acid than acetic acid. You're basically not going to get any of this hydroxide in solution, okay? Very small. It's such small amounts, not going to matter. So in this case, water is fine as a solvent. However, if you have a reaction where you want sulfuric acid to be the reactant, okay? You have a pK of -9. Well, it turns out that, yeah, water is going to abstract a proton from that sulfuric acid, and it's going to make hydrogen sulfate, right? And so you're going to have this equilibrium going on. Well, if hydronium has a pKa of -1.7 and sulfuric acid has a pKa of -9, this is definitely lower, right? That's definitely the stronger acid, and so the equilibrium is going to shift in the direction of the weaker acid, right? We've done this many times, so hopefully that's starting to look familiar too. So consequently, you're not going to have sulfuric acid in solution. This is what you're going to have. You're going to have a bunch of that stuff, okay? So let's look at another example. Water, matter of fact, this is our last example. Suppose you had a reaction like this. You've got some kind of alkyne. You've got a triple bond here, right? Got an alkyne, and you want to strip a proton off. So you have a really strong base here. Got a really strong base. You've got a lone pair of electrons here, and you want these to go here, right? And if those go here, this will go here, and you'll get this acetylide ion, okay? But what happens if you put water in here? If you put water in here, suppose you solvate this with water, you dissolve this in water, then this hydrogen, actually, this has a pKa of 16. This has a pKa of 25. This is a much stronger acid. So this is not going to happen. Instead, that's going to happen, right? Because this is the much stronger acid. So that's essentially what we're dealing with solvent effects. In order to prove that to yourself, I encourage you to put water molecules in. Of course, there's practice problems in the book. look at those practice problems and do the pKa's yourself and prove to yourself that if water gets in the way, if water is a stronger acid than the molecule you're trying to make, let's see, if water is a stronger acid than the reagent that you're trying to deprotonate, it's not going to work. I don't think I said that very well, but I think you get the point here. Go look at the problems in the book and use this as an example. Water works fine with acetate because this is not going to happen. We're not going to be stripping the protons off of water. And it doesn't work fine with sulfuric acid because you will be stripping those off because that is a stronger acid.